graphing an equation by plotting points. Before we do exactly what this title asks us to do, we're going to do one previous example. And this example asks us to use substitution to determine if either one of these ordered pairs is a solution to that equation or not. If there are solutions to that equation, then that means that point goes with that graph of the equation that we see there. If there is not a solution, then that ordered pair or that point does not go with that equation in that graph that we see there. So I'm going to do the first one, and then I'm going to ask you to pause the video and see if you can do the second one on your own. Now, this is an ordered pair of x and y. So all we need to do is substitute those values in for our x and y values in our equation and see if it comes up with the answer that we expect it to. In this case, the answer of 1. If it does, then yes, that's an ordered pair or that's a solution to that equation. If it doesn't, then our answer is no. That is not an ordered pair and that is not a solution to that equation. So let's go ahead and substitute it in. So 4 is going to go in for my x squared. So I have 4 squared plus negative 17 is going to go in for my y, negative 17. And we want to know if that is actually equal to 1 or not. So doing our math, 4 squared gives me 16. And 16 minus 17 gives me a negative 1. So negative 1 is not equal to the positive 1 solution that we were looking for. So the answer to part 1 is no. 4 negative 17 is not a solution to that equation. Meaning this ordered pair, 4 negative 17, is not on the graph of that equation. At this point, pause the video and see if you can come up with the answer to number 2 on your own. Okay, so I'm going to plug 1/2 for my x. So I have 1/2 squared plus, plug in 3/4 for my y, 3/4. And we want to know if that is equal to 1 or not. First, 1/2 squared, I square each individual piece. 1 squared is 1, over 2 squared is 4. And when I add that to 3/4, that does in fact give me 4 over 4, using my common denominator and adding my numerators on the top, which does simplify to 1. So that does match the thing that we're looking for. So the answer to this problem is yes. The ordered pair, 1/2 and 3/4, is a solution to our equation, meaning that this ordered pair will be on the graph of our equation. Now that we know how to use substitution to verify if points are or are not on the graph, we want to come up with our own points. So I have example 1 here, y minus the absolute value of x is equal to negative 1. The best way to graph these, as far as we know it right now, is to just create a whole bunch of ordered pairs, or points, plot those points, and then connect the dots. So I have outlined a table down here on the bottom left, which is going to be very useful in helping us creating these ordered pairs. The other very useful thing that we want to do is we want to go ahead and solve for our y variable there. That makes us filling in our table much easier. So to get our y completely isolated, the thing that we want to do is we want to get rid of this absolute value of x. And we get rid of it by moving it to the other side. So we would add the absolute value of x to both sides of this equation. So on the left, everything cancels out, leaving me with y. On the right, I have the absolute value of x minus 1. And notice that's what I have listed right here. Since I have it solved for y, creating my ordered pairs is going to be very easy. what we need to do is we just need to pick any x values. We need to substitute those x values into our equation and simplify, which is going to give us our y value. And that's going to give us our ordered pair of x comma y. So over here in the first column of the table, you get to be creative or not as creative as you would like to be. You can pick whatever x value you would like to pick. My suggestion is to pick something smaller. Okay? I would say 10 or smaller because on my graph over here on the right, notice my tick marks, they only go up to the number in 10 in all directions. If you do something larger than 10, that's perfectly fine. Just note that you might have to adjust your scale. So instead of your tick marks going by 1 as the typical way that we see it, maybe your tick marks would go by 2. So we'd have 2, 4, 6, 8, 10. Or by 5s or 10s or whatever you would like it to go by. So let's go back over here on the left. Let me go ahead and suggest that x becomes 5. Now I'm going to figure out what my y variable is by plugging it into this equation here. So my y is equal to the absolute value of 5 minus 1. The absolute value of 5 is positive 5. And when I subtract 1, that simplifies to give me 4. Whatever I get as my value here, that's going to be my y-coordinate there, which then gives me my ordered pair. We first picked out 5, and we saw that we got out 4 to go with it. So that gives us 1 point on our graph. So let's pick another one. Let's go ahead and pick 8. Okay? And I'm being as creative as I would like to be here, and you can do the same on your own. To figure out what my y value is, I'm going to plug this into my equation. Y equals the absolute value of 8 minus 1. That gives me positive 8 minus 1, which gives me 7. So that gives me my y value of 7, which I can plug in here. And that gives me the ordered pair of 8 that we picked and 7 that we got out. Now the thing that I don't suggest that you do is only pick positive whole numbers. So some other values that we can pick for x is we can pick negative numbers. So let's pick negative 3. So y is the absolute value of negative 3 minus 1. The absolute value of negative 3 gives me positive 3, and when I subtract 1, that gives me my 2 value. So that gives me my y value here, which I'll throw on my table there. And that gives me negative 3, 2. So let's pick another negative value. Let's go ahead and go with negative 9. So y is the absolute value of negative 9 minus 1, or positive 9 minus 1, which gives me 8. My y value, and that gives me my ordered pair of negative 9, 8. And I need to keep doing this until I feel like I have enough ordered pairs or enough points to come up with a clear graph of this equation. So you can try and plot these points and feel like if it's good enough, you're good to go. And if not, then maybe you need to pick a few more. Now I had only listed 6 lines in this graph here, okay? But you might need more or less than 6 points. So feel free to adjust that table however you would like to adjust it. So another point that I definitely suggest that you try is always put in 0. 0 is a very easy number to work with, so you might as well go ahead and use it. So y equals the absolute value of 0 minus 1, which is 0 minus 1, which gives me the y value of negative 1. So my ordered pair is 0, negative 1. Let's go ahead and do one more. Let's go ahead and pick out 1 in this problem. So y equals the absolute value of 1 minus 1, which gives me 1 minus 1, well, that gives me 0. So my ordered pair there is 1, 0. So we're going to plot these points and see if we feel like this is enough points or not. If it's not enough points, then we will just keep on going and create as many more points that we need. My first point is 5, 4. Give me that point there. Then I have 8, 7, negative 3, positive 2, negative 9, positive 8, and some other points are 0, negative 1, and 1, 0. Now, I'm pretty familiar with what these graphs look like, so I know what this graph is going to end up looking like. If this is not enough points for you, then maybe you need to plug in some more points to figure out what the graph looks like. So what this graph looks like is it's going to be a V. This point right here is actually the bottom of our V. So it's going to go up here on the left like this, and it's going to go up here on the right like that. So that's what the graph of this equation looks like. Now I'm going to show you how to check these graphs on your graphing calculator, but I'm just going to show you the basics of graphing with your graphing calculator. I'm not going to show you any neat tricks at this point. Okay, to graph things on the calculator, the first thing that you need to do is you definitely need to make sure that you have your equation solved for y, which we do here, and our equation is y equals the absolute value of x minus 1. So when we go to our calculator, to graph things, we are going to use this top left-hand button up here, which is y equals. You want to make sure everything is turned off, as you see here. So make sure that none of your plots are highlighted up here, and make sure none of your equations have anything entered in them over here, which mine does not. Notice it is y equals. So what we are going to plug in is the right-hand side of this equation. We are going to type in the absolute value of x minus 1. Now the absolute value is kind of tricky to find. It's under the math button, and then you need to go over to this NUM button. So go over, and the first thing that you see is ABS. That is an abbreviation for absolute value. So you can either hit the 1 button or the enter button to select ABS, and that gets pulled up in your absolute value. Now this is a newer edition of the calculator, so it shows you the absolute value bars, and you need to type in the inside. If you had an older version of the calculator, it would say ABS open parentheses, and whenever you're done entering your absolute value, you would close the parentheses, which is above the 9 button here. Inside my absolute value is the X button. The X button is this button right there. It says XT theta in. If you're in the right mode, when you push it, you will always get the X button. Now, I am done with my absolute value, so I need to push the over button, and my calculator is telling me to do so. If you had an older edition of the calculator, you would just close the parentheses. The rest of my equation is minus 1. So I hit in a minus 1. And then enter to tell my calculator that I am done entering in my equation. If I want to see this graph, I'm going to push my graph button on the very top right. And there we see the V that we have drawn by hand. So this is one way to check to make sure that you have the right graph of your equation.